Hey y'all, so in this video we're going to be talking about some GRE problems. So I wanted to go ahead and take a look at this one. So the idea here is that they're asking us if x plus y is equal to k turns out to give us something. So this is going to be our substitution, or they're acknowledging that this exists, that x plus y is equal to k. Then something could occur. Well, then we end up with this piece right here, the 3x squared plus 6xy plus 3y squared. So when we're dealing with this type of problem, we're going to end up being, they're giving us something to use later on. So this is going to help us. We may not know what it help us with right away. Just depends. So the first thing I'm going to go ahead and look at, my first aspect that I want to look at is over here at the 3x squared plus 6y plus 3y squared. So what I can see right away from this type of problem, or from this information that they're giving us, I notice right away that this turns out to be a factoring problem. So when you go through a bunch of these a factoring or expanding binomials into like these trinomials, we can go ahead and start noticing that certain patterns come out to exist. Well, the first thing that I'm noticing is that the x squared and the y squared. So what I normally say that okay, this is going to occur is because it's being FOILed or something's being multiplied by itself, because that's the only way for the outer terms to be squared is when we have the same x's and y's being multiplied. So a way that could be written like this is we go ahead and say x plus y times x plus y. So when we FOIL this out, so when we start FOILing this out, we'll notice that the first term gives us x squared. We'll notice that the inner terms will give us a 2xy. And then we'll notice the outer terms give us a y squared. Well, when you notice these, you're going to go ahead and see that, oh, okay, well, we have x squared plus 2xy plus y squared. So we notice right now that, hey, we have the same three pieces. We have x squareds, y squareds, xy's, but the numbers aren't matching up the same. So what we'll go ahead and do is look at what they have in common. Now, this is what we'll say is usually the greatest common factor, or we'll say what do they have in common. What the x's, they don't share any x's in common. They only share any y's in common. The only thing that they do share is a multiple of 3. So what we're going to go ahead and see here is that these have a dealing of 3 here, each one of them. So when you pull it out, we get to go ahead and say, and remember this is factoring out. So factoring out, so when we go ahead and look at that, well, if I take away that, I'll have an x squared. If I take away a 3 from here, that leaves me with a 2. So you can think of it like division. That'd probably be the easiest way to be in the understanding of what factoring out is. So that's going to be a form of division. So then we're going to be left with 3 divided by 3 gives us y squared. So that's why I'm saying it's a form of factoring. So what we notice is that, oh, well, when I have this x plus y, when they're multiplying each other, it's really just going to give me out the same thing. So this is that was a big indicator for me that, oh, we're going to be FOILing, or we're going to be doing something with distribution. So now what we can go ahead and do is simplify our problem to look smaller, to help us solve the problem. So what I'm going to say is 3 x plus y, x plus y. And we get this because we said from earlier that, like, from our prior knowledge. So this is what happens when you do it a couple of times, just start to notice this. So this is my first indicator, was x plus y times x plus y. Well, what we could do is we can simplify this one more time to write it in a form that's a little nicer. Well, hey, doesn't this look very similar to what we started off with at the beginning? I know it's not written in the same format or in the same aspect, but what we can go ahead and do right now is we can go ahead and say, hey, I can do something to the x plus y is equal to k in order to help me get the same thing out. Well, what I can do here, and this is usually going to be my third step, I'm going back to what is given to me. And the first thing I can go ahead and do is say, okay, the outcome of it needs to be squared. So I need x plus y raised to the second power. Okay, well, I'm given this. So now it looks very similar to what I have. And you can do this because of the algebra rules. So if I square something on one side, I have to be able to square it on the other side. So what I'm trying to do is make it look very similar to what it was already. So what it is now telling me is that when I have x plus y squared, I can easily get k squared. So what that is telling me is I was like, oh, the representation is the same. So in math, you're allowed to do the same stuff. You're allowed to work with the same stuff that you want to, as long as if you changed it or modified it in a way that it is mathematically okay. And a lot of the time, what we mean by that is just make sure that whatever you're doing is whatever you did to one side is you did to the other. So always keep that in mind. So now what we can go ahead and do is say, oh, okay, well, we have x plus y squared is equal to k squared. So what I can do here now is just say 3, and we'll do substitution. So wherever there's an x plus y squared, I'm going to replace this with k squared. So then now I can say k squared. So then the overall solution to this is then when I'm given this long 3x squared plus 6y plus 3y squared, it's going to be equal to k squared, knowing that I'm simplifying it, given that this information already is true. So that's going to be our answer. So if you have any more questions on the GRE or any SAT or anything like that, you can go ahead and email me or leave a comment below, and we'll go ahead and work with those. Thanks a lot, y'all.